Hello and welcome today. My name is Corey Heisey and I'm a mechatronics engineer. I have a bachelor's from Canada, UBC, mechanical engineering, and then I have a mechatronics master's from Deggendorf in Germany with 6 years of work experience. And today I'm going to go talk about TF Lite Micro, ESP-TF Lite Micro. And first I have the ESP32 microcontroller. Yeah. We have here. Where is it? No. ESP32 microcontroller. That's flashed already. And I use a few different libraries or tool chains here, toolboxes, tool libraries, tool things. And what I have flashed on there is just a hello world example that I don't really know. It just makes a sine wave. So it has x as input and y, or x and y equals sine x. So you can do what you want with it, but I just flashed it from the examples from the repo. And I haven't used any TensorFlow machine learning tiny or micro libraries before. I've heard of them before. Of course. I heard that they're not like so great. They're pretty dedicated, specific use cases. And I've seen like the new a lot of the new Jetson Orion Nano, Jetson Orion Nano, for having maybe more of like a TensorFlow Lite, or even you can even have you can run a Llama and stuff on it, open source LLMs. But I thought, okay, well, let's get down to microcontroller and see what kind of libraries they have. Obviously, it's a lot more limited. And eventually try to get into not using libraries and running sort of the inference and neural networks on a lower level. But the first stop would be to get going one of the TensorFlow libraries, Lite Micro. So I'm going to walk you through it here, what I did, because there's a few steps, but not too bad, and I got it working, and might as well make a little quick tutorial here. So we got here, and this is the documentation from ESP-IDF, ESP-IDF. So, introduction, let's just walk you through. Okay, you need a ESP32 board, I got that. USB cable, pick one, I think mine's Vroom or W Rover Kid, same thing. Okay, how the architecture is, blah, blah, blah. Windows installer, but I have Mac OS, so it was a lot easier. So first you need to install the ESP-IDF. So I was able to use just this command, brew install cmake ninja dfu util. And it says if you have an error, I didn't have an error. So the install you have to kind of go through yourself if you're Linux or Windows or Mac OS. Something Python. Okay, I already have Python 3. You need Python 3. Brew install Python. Okay. Yeah, so you pick whatever directory you want. The make directory, ESP, CD ESP, and then you clone it. And then set up the tools. Inside the ESP-IDF, you also need to install the tools used by ESP-IDF, such as a compiler, debugger, Python packages, etc. for projects supporting ESP32. So just need to run this install script. And the above command, or fish, the above command installs ESP32 only. If you tend to develop projects, okay, fine. Okay, I only need the ESP32. And then alternative downloads. the one line you need to do was this one, I'm pretty sure. Customize the tools installation. You need to source it. Yeah, it's this one here. So if I wait, ESP blah 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 blah. Yeah. The install tools are not yet added to path environment variable to make the tools usable from the command line. Some environment variable must be set. So you can add this to path. I haven't yet. I just kind of sourced this and then it worked. Or this one you need to put in your path directory file. Okay, so we can go to the here, and if I go back. So here's my, CD ESP, like it said, and then I have, yeah, you can see, okay. Yeah, so the first directory clone was so git clone blah 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 for the ESP-IDF. So CD ESP-IDF. And then we go examples. No, wait. Here, if I go here, IDF pi should do something. But if I go another, yeah, and I go IDF pi, this is like the run command. It says I don't know anything. So if I go here, I just need to do, no, I'm in the ESP, so in ESP IDF export.sh, I think that's what it said. Yes, and then, this one should work. Okay, nice. So if I go idf.py, it recognizes it. So right now it's not added to my path. I would have to run that source script every time, but you can add alias get IDF and attach it to your Z profile file in macOS, which I don't really want to do right now, and I haven't done it, but that's okay. And then it says to copy. You can copy your example. So for the IDF one, I copied it to the main directory of the project. But for the ESP TF Micro, I cloned this one. So let's see here. I went. Let's find here as well. So this hello world there that you see there is from the ESP-IDF examples. So for the other one, the ESP-TF Lite Micro. See examples, because you can just build it and flash it from the pulled repository, and if you need to, you just pull it again. But you could copy it if you really want to edit it and make your own, or fork it, of course. And then hello world, and then we have these files, and we go here. Yeah, so we're in the hello world here. So we have a build. I guess it's because I already built it. I built all of these examples. Main. Your main file. Main functions. Let's see if it has this. the sine equation. Inference count. Okay, so it's doing something, that's for sure. And the we have so we need to set the target device, and you can run this configure page or window, and then build, and then flash in which port. Yeah. So let's go back and go here as well. So IDF pi set target ESP32. Okay. And then you can do, what was it? It's IDF pi menu config, and it launches this. But the default settings are fine, I guess. I don't know when you need to do this. I guess when you're building projects, not just setting up examples. Let's see, I2C configurations. Yeah, so it's lots of nice little TUI instead of having to do it in the files. So quit. And then the next one was IDF pi build. Yeah, it's already built, but it's building again, so it's doing the full build. It's not for a bit long though. Building. Okay. And then freaking. Let's go to this one. And if I go like this, ls dev text, the port number TTY, okay, TTY, like that, something like that. Yeah, that's what it was. Here, if you run this ls dev tty dot star, you can see what ports, serial ports are available. So I have Bluetooth incoming port from my keyboard. Debug console J's T5 is the headphones. They're not attached or connected, but they're just there. And then the USB serial 00001 is the port for the ESP32 that's connected right now. So, and then the next command was IDF p port. Let's see, port 1 flash monitor. So yeah, then you just do the port. -p for port, dev tty USB serial 001 is the port, and then flash and monitor. So we flash again just to show. And that's the serial monitor. It's flashing. And it says, okay, flash, good to go, boot, factory, and the partition table. And it sends out this sine curve, so X and Y for sine. Then just increments through it. Again, I'm not really sure what, I think it's just a hello world example. I'm not really sure what the inference is supposed to do or what the model actually can do with that, but that's how you flash it. And I like the ESP-IDF flashing instead of Arduino IDE, and also instead of Platform IO. On Windows, it's a little difficult to set up. I remember trying to set it up, but it's probably easier Windows subsystem for Linux, WSL, or Mac or Linux, but that's probably the only difficult parts. But you just use WSL on Windows and do the Linux install is probably the best bet, in my opinion. Let's see Windows. I don't even want to look at this, doing this. That's why I prefer having a Mac OS, Unix, or Linux, but yeah, so that's good. And we can go here, maybe check out the code a little more. Let's see, model. Okay, it's just that. Output handler, main component constraints. No. IDF component, okay. Nice. For flashing, I guess. Main functions. So there's the main functions. Yeah, so that's what I've been doing today, and it's nice that it was able to flash it. I'm trying to set up the examples. They have micro speech. We go README. This example shows how to run a 20 kilobyte model that can recognize two keywords, yes and no, from speech data. The application listens to its surroundings with a microphone and indicates when it has detected a word by displaying data on a screen. But I need a microphone and set up the pins and all that, but I haven't. But there was one that is person detection, and I have a ESP32 cam. So I flashed this one on there, but it still needs some tinkering because it needs to know what to do, right? What pins, what camera. And it has like ESP32 cam on there, like in configurations, but I need to still like set up what to do with it. So I have a SD card in there, and I can, so I had the example of taking a picture. So you have a button hooked up through the GPIOs or a motion sensor. It takes a picture and saves to the SD card that I have on there. And so it'd be nice to have an example of, oh, is it a person? And then take a picture, just for example. Having the picture more to like a network that I could access through a browser, through secure browser, HTTP setup would be a lot better than local SD card for what I'd want. But just to get the example working, and then I can validate it and check the SD card. But yeah, I basically have, I'm not sure how well these TF Micro libraries work. That's why I'm tinkering with it to try to see how it can work and how to improve it and what kind of optimizations there can be and use cases and where and when to use it. So yeah, that's why I started tinkering with TF Lite Micro. And it's relatively easy to get to flash and get on there, to build a model or to train a model, to use a model or to use the model. I don't know yet. So that's obviously the next sort of steps, but yeah. Hope you enjoyed watching. Consider subscribing, and until next time, bye for now.